So up till now, you guys have looked at angles. Generally, you've said an angle measures greater than 0 and less than 180 degrees. For example, we have something here, an angle like so, an acute angle between 0 and 90, or an obtuse angle from 90 to 180. Certainly, you've heard of 370-degree angles, negative 430-degree angles. So how does that come about? It comes about as follows. We can take an angle and pick one of the two rays to be what's called the initial side, lie that along the x-axis as an initial side, and then we can view an angle as rotating that initial side into a new position. So in other words, I'm going to take that angle and rotate that initial side till it becomes the terminal side. And if I do so in this way, such that the vertex is at 0, 0 in the coordinate plane, the initial side coincides with the x-axis, and the terminal side coincides where it ends up. We've said we've put the angle into standard position. So if I go ahead and put this other obtuse angle here down in standard position, I'm going to put the terminal side here on the positive x-axis. I'm going to rotate about until I get the initial side in the x-axis, rotate around until I've got the terminal side over here, and I've put this angle, placed this angle in what's called standard position. So, initial side, rotate, and we've got a terminal side. Notice which way I've rotated in both of these cases. I've rotated counterclockwise. So, as we've just said, if we're going to go ahead and look at an angle, initial side here along the positive x-axis, terminal side is going to be done by rotating out to a position, rotating that the initial side out to another position. In this case, if I rotate in the counterclockwise direction, that's going to give me an angle of positive measurement. But I also could rotate in the opposite direction. If I have my initial side here on the positive x-axis, and I go ahead and rotate in the clockwise direction to a position, here's my terminal side, that clockwise rotation gives me an angle of negative measurement, and that's simply going to be the way that I distinguish between positive and negative measure. So one thing we might consider that you might not have thought about in the past all that much, but which we'll consider now, how do we define, for example, an angle of 1 degree? We're going to define an angle of 1 degree as an angle which consists of 1/360th of a rotation all the way around the origin. So if I have my initial side here and I rotate 1/360th of the way around, that angle is going to be defined to have a measurement of 1 degree. Obviously then if I were to take an angle and take that terminal side and rotate all the way around 360/60ths, if I rotate all the way around, if 1/360th is 1 degree, then rotating all the way around will be 360 degrees. So up till now, we've talked about angles having degree measure, and you guys have been very good with degree measurement. So now we're going to define a new unit of measurement for angles. We put our angle here in standard position. Here's my initial side. I'm rotating a certain amount to get to terminal side. And imagine, if you will, if I've got an angle in standard position, I can always superimpose a circle centered at the origin on this diagram. And that circle will have a radius r. And I'm going to look at the arc that the circle subtends, or that the angle subtends here. This angle, if I rotate the initial side up to the terminal side, cuts off or subtends an arc on this circle. And we're going to define the radian measure of an angle to be the ratio of the length of that arc on the circle S divided by the length of the radius of the circle. And what we could do is we could say, well, let's let that circle have a specific radius of 1, in which case my radian measure would be the arc, which would be S, whatever that is, divided by the radius is 1, which would be S. So in other words, the radian measure of an angle is the length of the arc on the unit circle that the angle cuts off. And that's it. That's the definition of radian measure. It's either the ratio of arc to radius of a circle of some general radius r, or if it's a unit circle, it's the ratio of s to 1, or simply s. For this angle right here, the radian measure would be the distance that an ant would walk along the circle of radius 1 from the initial side until it hits the terminal side. Now, let's think about this for a minute. We have looked at a couple angles that clearly are acute or obtuse. Let's suppose we're looking at an angle if our initial side is here and our terminal side comes all the way around. So that's going to be a 360-degree angle. If I have that unit circle on here, what's the circumference of a unit circle with a radius of 1? And the answer is it's 2 pi times 1, or 2 pi. That means we have a conversion factor set up. 360 degrees is 2 pi radians. Divide that by 2, 180 degrees is pi radians. And that's key. That's the absolute key factor to consider, remember, when you're going to do converting from radians to degrees and vice versa. If I have 180 degrees equals pi radians, if I divide both sides by 180, I'm going to get 1 degree equals pi 180th radians. And if I go ahead and divide both sides by pi, I'm going to get 1 radian equals 180 over pi degrees. So the question you might be asked is, hey, how many radians is 63 degrees? And the answer is, well, that would be 63 times pi over 180, and I could simplify that and give a decimal approximation. Or if I wanted to know, hey, how many degrees is 2.1 radians? Well, I would multiply that 2.1 by 180 over pi, and again, I could get a decimal approximation for that. It would be 2.1 times 180 over pi degrees. So coterminal angles. Coterminal angles are simply angles which have the same terminal side. For example, we have up here a initial side, which we always put in our positive x-axis, and I could spin up to get a terminal side here. I also could have spun all the way around and kept going to get to the same place. So this acute angle and this angle that is more than 360 degrees, or more than 2 pi radians if we measure in radians, those two angles share the same terminal side, hence they're called coterminal angles. I also could spin the other way. Let's suppose I look at this and I spun in this direction. That would be a negative angle, negative measured angle. So this angle right here, this acute angle, positive measurement, is going to be coterminal with this angle, which is a negative measurement, same terminal side. So, for example, suppose I want to find angles that are coterminal, a positive and a negative angle coterminal with 57 degrees. Well, 57 degrees is some sort of acute angle, say somewhere in there, and I want to wind up getting a positive coterminal. Well, I simply could go ahead and spin around, and get to the same place again. So 57 plus 360 degrees would be a positive coterminal. To get a negative coterminal, I've got to say, well, if I spun around this way negatively to get to there, that's going to be my negative measurement. And if this is 57 degrees here, what's left? It's going to be 360 minus 57, or 303, and so a negative coterminal angle would be negative 303 degrees. So quick conversions, angles that we're going to want to convert with are going to be multiples of 30, 45, 60, 90, 180, and 360. Those conversions each way you're going to want to be good with, and the key here is you want to start with your basic conversion definition that pi radians is 180 degrees. So for example, 45 degrees we know is going to be 1/4 of 180. Why? 45 times 4 is 180. 45 and 45 is 90. 90 is 180. I got to see 45 as a quarter of 180. Since pi is 180, a quarter pi will be 45 degrees. 30 degrees. 30 is a sixth of 180, so a sixth of pi, and commonly we're going to write that as pi over 6. 60 is a third of pi, a third of 180, so pi over 3. And we're going to also want to look at other numbers, multiples of pi. For example, if I wanted to look at 2/3 of pi and consider that in terms of how many degrees that would be, I could view that as 2 pi over 3s, 2 60s, or 120. I could also view it simply as 2/3 of 180 and just do 2/3 of 180 immediately and get 120 degrees. So again, a couple more practices here. For conversion, I got 11 pi over 6. I look at that and say 11 pi over 6, it's got something to do with pi over 6. Well, I'm going to think of 12 pi over 6. That's all the way around. 12 pi over 6 would be 360 degrees. So I'm pi over 6 short of that. That's 30 degrees short of that. 30 degrees short of 360 is 330 degrees. How about 7 pi over 3? Well, 6 pi over 3 is 2 pi. So if I go 1 pi over 3 more, that's a third of 180 more. That's 60 more than 360. So 360 and 60 more is 420. 3/4 pi, 3/4 of 180, 135.